Hello Gators, this is 6-4, proving a quad is a parallelogram, day 2. Let's take a look at another way we can tell whether a figure is a parallelogram or not. Let's take a look and mark up AX congruent to CX, BX congruent to DX. This is going to allow me to say that this triangle right here is congruent to this triangle right here. Notice that they have two sides and they also have this vertical angle here. So I can say triangle BXC is congruent to triangle. Now angle B has to go with DXA. And this is by side angle side. Now from these two triangles I can get BC congruent to AD. So now I have one pair of opposite sides congruent. Now I can work with these triangles right here, this triangle here and this triangle here, and I can get these triangles congruent. Triangle BXA congruent to triangle, and again B has to go with DXC, again by side angle side. Now these triangles will give me AB congruent to CD, and this is by corresponding parts of congruent triangles are congruent. And a short way to write it is CPCTC. Now once I have shown that this side right here is congruent to this side and this side is congruent to this side, then we can use one of our former theorems. If both, remember that we have to say if both pairs of opposite sides are congruent, then it's a parallelogram. So just having diagonals bisect each other, we're going to be able to say yes. Let's take a look at this next theorem, and this is what the theorem says. If you see diagonals bisecting each other, you can say it's a parallelogram. Let's take a look at this situation. If I had this information, is this enough to determine whether this is a parallelogram? Well, let's see. Let's draw a diagonal. And when we draw the diagonal, we know we're going to have a reflexive side. We already have one side here. Now this arrow means these sides are parallel. So we know that angle of this angle right here is going to be congruent to this angle right here. So these two triangles can be congruent by side angle side. Therefore angle 1 and angle 2 will be congruent by corresponding parts of congruent triangles are congruent. Now once angle 1 and angle 2 are congruent, well, I'm going to just go ahead and put this in this, then that's going to tell me AD is parallel to BC. AD parallel to BC, because if alternate angles are congruent, then the two lines are parallel. Since I have AB parallel to DC, and I also have the other pair of sides parallel, this is a parallelogram. That's what parallel means. Both sides are parallel. So indeed, this is enough to say the quad will be a parallelogram. And that's our next theorem. In our next theorem, if you can tell me that one pair, if one pair, not both pairs, but if one pair are both congruent and parallel, then we can say the quad is a parallelogram. Let's take a look at this and decide if we have enough to prove this is a parallelogram. Let's look at this. Notice that we have opposite sides congruent, and the answer is yes. And we say if, don't forget the word both, if both pairs of opposite sides congruent, then we say it's a parallelogram. Let's look at this side. This is our new one. Remember, we have one pair of sides here that are parallel and congruent. So we're going to be able to say yes with our brand new theorem. If one pair are both parallel and congruent, then it's a parallelogram. Let's take a look at this one. This has one diagonal that's being bisected. We have one pair of sides. We do have vertical angles, but you can see this is not enough to get triangles congruent, and it doesn't match any of our theorems, so we're going to say no. Here I can see that this is the midpoint for this diagonal. It's also the midpoint for this diagonal, so I'm going to say yes. This is one of our new ones. If diagonals bisect each other, then it's a parallelogram. If diagonals bisect each other, then it's a parallelogram. Let's take a look at this one. I have one pair of opposite angles that are congruent, and I don't know anything about those, so I have to say no. Here, this looks a lot better, so I say yes. If both, don't forget the word both, if both pairs of opposite angles are congruent, then it's a parallelogram. All right, for what values of P and Q is A, B, C, D a parallelogram? Now this is about diagonals, and what we want to do with the diagonals is we want to make sure they're going to bisect each other. So we want to make sure 3Q plus 1 equals 2Q plus 3. Subtract 2Q on both sides, that's Q plus 1 is equal to 3. Therefore, Q is equal to 2. If Q is equal to 2, then this length will be a 7. And if I make that, that'll be a 7. So this will be 7 and 7. Let's change color. Now I'm going to work with these sides. I want to force this and this to bisect each other. So we want to make sure we set them equal to each other because we want that to be a midpoint. Subtract 5P on both sides. Subtract 1 on both sides. And then P will be equal to 1. If P is equal to 1, then this length will be 8. And if P is equal to 1, this side will be 8. Now, if the diagonals bisect each other, which we finally have done, then we can say it's a parallelogram. And here's the concept summary. These are all the ways you can determine if something's a parallelogram. If any of these things are happening, you can say it's a parallelogram when you're looking at sides. And when you're looking at angles, you can look at this if one angle is supplementary to both consecutive angles, or if two pairs of opposite angles are congruent, then it's going to be a parallelogram.